you by thesis123.com. I learn and teach online.
Here's the next question, 42. Determine the correctness or otherwise of the following assertion A and the reason R. So the assertion says that fast decoupled load flow method gives approximate load flow situation because it uses several assumptions. The reason being, accuracy depends on the power mismatch vector tolerance. Okay, so a lot of technical terms here where you will have to analyze. So the assertion talks about fast decoupling load flow method having several assumptions. Now when talking about load flow, the power flow equations are resolved into two sets. You should be quite familiar with that. One set is P theta and the other is Q V. The decoupling of these parameters, it makes it possible to solve the two sets of equations separately. So if these equations are linearized, when they are linearized, the equations that we get or those that are obtained is called fast decoupled load flow. So in the solution process while solving, the results of the P theta equations are used in order to solve the QV equations, or vice versa. We can use the equations of QV and solve and find out the equations of P theta. So in such circumstances, we see that there are not many assumptions. There are no assumptions in fact. So this fact saying that it uses several assumptions is false. So this tells us that A is false, it is not true. And if you look at the options here, the fact that A is false is present only in option D. Oh, option C is also given. Okay, so it's either option C or option D, one of these two which says that A is false. Now A is false because fast decoupled load flow methods don't have several assumptions in them. Now we will have to look at the reason. The reasoning is said that accuracy depends on the power mismatch vector tolerance. Now the first thing you need to do is think about what power mismatch vector tolerance is. Now it is true, R is actually true because the reason is true, since the accuracy of this fast decoupled load flow method, it does depend on the power mismatch vector tolerance. Now power mismatch vector tolerance is defined, I think I better write that down here for you to note. Okay, so power mismatch vector, first we will look at power mismatch vector. Now the phrase written in the question is power mismatch vector tolerance. So first we'll talk about power mismatch vector. So this is defined as the vector of the differences between the specified and calculated power. These are actually power injections, specified and calculated power injections at each bus. So power mismatch vector is the vector of the differences between the specified and calculated power injections at each bus. So it is important to check the power mismatches to be within a specified or within a pre-specified error tolerance. So that is what tolerance means. It has to be within a certain limit, the differences of the power injections. So the specified, or in fact it is pre-specified error tolerance Now in general it is to be at 0.001 pu. So if it is within this amount, then it is known to be a success. If it is not, then there is some problem. So basically at say a certain bus, now here it is the power injections at each bus. So we'll take at some bus K. So the difference in the active power at that bus can be written as the specified value minus the calculated value. Similarly, for the reactive power at that same bus, we can write it as the specified value of the reactive power minus the calculated value of the reactive power K. So if this difference results in a value less than 0.001, then the load flow is supposed to be a success. So this means that the accuracy definitely depends upon the power mismatch vector tolerance. So R is correct, but the assertion is false because it doesn't take into consideration several assumptions. So A is false, R is true, which means that option D is the right answer. Well, I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.